Welcome to Scholar Interview. Today's episode, we are excited to have Professor Carlo Santulli, an expert in sustainable composite materials, with us. Thank you for joining us.
Thank you. Thank you.
So let's get to know you a bit better. To start, could you share a bit about your academic journey and research background? What sparked your interest in specializing in sustainable composite materials?
Yes, I'm always been working on composites, and of course, over time, the interest for better sustainability and using also secondary raw matters, so waste for the production of composites has been more increasingly important. And therefore, of course, I have a personal interest in sustainability and circular economy, but also the needs that the industries and society have into being more sustainable and provide better use of the materials, better use also of the waste, which we have abundantly in terms of biomass, and not only, also in terms of ceramics, sparked this interest. So in reality, now I am working a lot about biomass composites and also secondary raw material composites, also in marine environment. So yes, that was a normal evolution of my work on composites, to try to be more sustainable and more friendly with the environment.
From what we know, you are serving as a guest editor for JMSE. What inspired you to take on this role?
I think that the evolution of the sea related issues of use of the material, in particular the disposal, the end of life of these materials, considering fiberglass and so on, was an important drive for me to be more involved in this field. So that's why I have taken this role in the Journal of Marine Science and Engineering, which is one of the most renowned journals in this field. So it was a natural choice, I would say, which is connected with my present research interests.
Thank you so much for your contribution to our journal. Sustainable composite materials are becoming increasingly popular in marine applications. What do you see as the key advantages of these materials compared to traditional alternatives?
Well, until a few years ago, we didn't care much about the disposal of fiberglass. The end of life was cumbersome and sometimes even very polluting. And this theme is coming out, and it is important that we try to understand whether we can produce a material with the same performance or a performance close to fiberglass, the traditional fiberglass, with the typical thermoset resins like polyester, unsaturated polyester, vinyl ester, or epoxy. And I'm sure that we have a lot of possibilities open at the moment, because we have a lot of, for example, natural fibers, but also sea-originated refuse, which we can use into materials, and also together with the development of bio-based matrices, which can be used as well in combination with them. So there is a lot of possibility, which has been exploited very little so far. So there is a lot to do in the next future.
What do you think are some of the biggest challenges in developing and applying sustainable composites in marine environments?
The main challenges are correlated to the sea environment, which is very aggressive in terms of presence of salt water, in presence of biological organisms, then biofouling. And it's also difficult to have a prolonged time testing, so that we can make some predictions in order to assess which would be the life, the service life, the duration, and I would say the success of the life of these components. So we need some aging testing for longer time, and we need to reproduce as much as possible the real condition that the material will encounter at sea. So this is going to be expensive. This is going to be also difficult for us in terms of taking out the results and making some sense of them. But I think that's the way to try to demonstrate that sustainable composites can really replace traditional ones into these applications.
Fibrous reinforcements like natural fibers and bio-based resins are commonly used in eco-friendly composites. How do these materials hold up in harsh marine conditions like saltwater exposure and UV radiation?
Well, there is a lot of difficulty in terms of salt water, the effect also of depth into their use in sea, and of course the contamination, the biological contamination which they are prone to. There's also another difficulty in selecting the fibers, because there are lots of natural fibers which can be potentially used in this field, and also some fibers which originate from the sea, like algae or Posidonia. But the main question is that there have been some fibers which have more success, for example, flax, hemp, or jute, sisal. But in reality, it is such a large variety of fibers. There are studies of over a few hundred fibers in general applications and also in construction engineering. And it's worthwhile understanding whether these can be applied, at least a part of them, into the field connected with salt, the salty environment. And therefore, of course, we need more experimentation and more comparative studies among the fibers, among different fibers and among different fiber matrices, and that's important also for a journal like yours.
Recycling and end-of-life management are key to sustainability. Are there effective strategies for recycling marine composites materials, or do they typically end up as waste?
I would say not at the moment. We are trying to develop some strategies, but in reality, the main question now is to produce these materials with renewable resources in order to reduce their depletion. But I am sure we are going to develop later on some studies, and there is the possibility that we are able to exploit contamination, biological contamination, as a way for final end-of-life disposal. So the question is open. I wouldn't say that we are close to the goal. I would rather say that we are trying to experiment a number of solutions to see which might be the most suitable for these kind of applications.
Submarine composites are now using innovative materials like algae-based fibers or recycled ocean plastics. What emerging trends or breakthroughs in this area do you find most promising?
Well, the use of algae, it's important because if you want to use waste in general terms, you want to avoid the transportation problems, and so you are going to use in a 0-kilometer philosophy. And they are also more accustomed to the marine environment, and therefore it would be more interesting to use them. I find interesting the way that they are able to adapt to sea pH, and the possibility they are going to withstand also aging process. Especially in combination, we have also the possibility in the long run to use also bio-based resins, like based on on algae as well, on alginate and so on. So there is a possibility. There is a possibility to evolve in the future. Of course, this is a new concept of material because we are accustomed to non-alterable, to persistent use of materials and to avoid biofouling. In this sense, the material would have an aging process which is going to be much different, and there is the question on how to protect them from biological contamination by coatings and so on.
Genetic inheritance doesn't apply to materials, but durability and environmental impact are inherited through design choices. How can engineers ensure that sustainable composites maintain performance while minimizing ecological harm?
Well, I am not sure about that, if it is easy to do that. Of course, the combination, the suitable combination of polymeric, like natural fiber, and ceramic elements, which might be taken from the sea as well, like for seashells and so on, might tailor the durability process of the material and take them into possibly comparing with fiberglass in the end. We need to consider that the cost is much more reduced. And it is also important that we are able to develop materials that can self-heal themselves or that we can repair, because one of the limits of fiberglass is the difficult repairability. Maybe with this kind of materials we are able to ease the process of repairability and therefore enhance their service life and make it also more successful.
Thank you so much for sharing your valuable insights on sustainable composite materials and their future in marine applications. It's been a pleasure having you with us today. We look forward to seeing how your work continues to shape this exciting field.
You're welcome. Thank you.